Hey guys, it's me, Miss van Gastel. Hey, I just want to let you know that you did great on the test yourself of chapter 7, so I'm proud of you guys. Hey, I just made an explanation video with the most common mistakes that you did on the test yourself. So hopefully that's helpful. Make sure you have your book and your notebook in front of you and then correct all your answers when it was wrong. And these are the exercises that we are going to discuss. Good luck! 51c. This is a square root 25pq divided by square root 5p. What you need to do is, when it's both the square root, you can make one big square root of it. So it's 25pq divided by 5p. And now you can just divide it by each other. So 25 divided by 5 is 5. So again, a big square root. So leftover is 5. Over here's leftover is 1, but you don't have to write that down. If you want to, you can. Let me just do it. And then p, q, and p, the letters divided by each other. How do you do that? When the letter is the same, you can do the exponents minus each other. This exponent of 1, exponent of 1, exponent of 1. And in this case, the letters are the same. So p by the power of 1 and p by the power of 1. You do 1 minus 1, that's 0. That means that p is gone. There's no p anymore. There is a q, but there's no letter here. So a number or letter or whatever divided by 1 is always that same number. So this is actually square root 5q. And that is the answer. In exercise 51 it says write with 1 square root 7 square root 3. To write it as 1 square root you have to know that there's a times here. And then you can also rewrite 7 as square root 49. It's exactly the same, so just write it differently. And this is square root 3. Now, you know that you can do square roots times each other. So you just do 49 times 3, which is 147. And of course, in a square root. So this is written as 1 square root. 10 square root 3p divided by 5 square root p. First you do the normal numbers, which is 10 divided by 5, that's 2. And then the leftover is 3p, and over here square root 3p, and the denominator is square root p. Now, let's have a look at the square roots. The p is the same, this p by the power of 1 and p by the power of 1. Do the exponents minus each other, so 1 minus 1 is 0. There's no p anymore. So the leftover is just at 3. So that's 2 square root 3 divided by, there's nothing here, but there is a 1, of course. There's always a 1. Now, divide by 1, that's just the numerator. So it's 2 square root 3. Now in the exercise it says write as 1 square root. This means that we're not done because there's a 2 here. I'm going to change that 2 into a square root. Let me do that here. So this is going to be square root 4 and there's a times in between. So times square root 3. Square root 4 times square root 3 is square root 12. This is the answer. So this is actually square root 12. Also in this exercise, write as 1 square root. So square root 65 p by the power of 3 q by the power of 2 divided by square root 13 p by the power of 2 cubed by the power of 2 is, first of all, 65 divided by 13. And that is 5. So this is 5. And then p by the power of 3 divided by p by the power of 2. Exponents minus each other. 3 minus 2 is 1. So you have p by the power of 1. And then q by the power of 2 divided by q by the power of 2 is 2 minus 2 is 0. So there's no q anymore. This is leftover is 1. But you can write this down as square root 5p. So that's it. T2. Write down whether or not each of the following statements is true. If a statement is not true, give an example to show why. You guys had problems with exercise D. The quotient of 2 natural numbers is a real number. Now, first of all, you have to ask yourself, what's a natural number and what is a real number? A natural number is all numbers that are positive and are whole numbers, but it starts with 0. So 0 and 1, 2, 3, 4, 5, 6, and so on and so on. And a real number, what's a real number? Every number is a real number. So a whole number, positive, negative, half a number, maybe a fraction, maybe a square root, maybe pi, even pi, or not just square root 16 because that's 4. So that's a whole number, a natural number. But for example, also square root 10 or square root 2. That's all real numbers. Every number is a real number. Now, let's go back to the question. The quotient of 2 natural numbers is a real number. What's the quotient? A quotient means divided by. So let me just divide 2 natural numbers by each other. For example, 6 divided by 2. 6 divided by 2 are 2 natural numbers, and the answer is 3. Is 3 a real number? Yes, because every number is a real number. So you can do this with all kind of examples, but you already know that the result is a real number because every number is a real number. So is the statement true? Yes, it's true. And also E was the most common mistake. The difference of 2 fractions is a whole number. Is that true or false? The difference, so that means minus each other, and 2 fractions, we know what a fraction is. For example, a half or a 3/4 or 1/4 or 2/3. And the difference of them is that a whole number. What's a whole number? That is can be negative or positive, because if it's only positive, it's called a natural number. So it can be also negative, but it has to be a whole number. So for example, -2, -4, or +3, 4, 5, etc. Now, the difference of 2 fractions. For example, 3/4 minus 1/4, that's 2/4, so that's a half. Is that a whole number? No. Or, well, then the statement is already false. I can make up lots and lots of more examples, but with this just small example, it's already false. So when it's false, you have to say false and then give a reason with maybe an example. Exercise T3, it says, look at the numbers. I wrote all the numbers here. And E, it says, which of these numbers are prime numbers? Well, what is a prime number? That is divisible by 1 and by itself, but only that. So not divisible by 2 or 3 or 5 or whatever. Well, 2 is only divisible by 1 and by itself. 3 is also a prime number. It's only divisible by itself, so 3 and 1. 7 is also a prime number. What about 10? I can divide 10 also by 2 and by 5, so no, it's not a prime number. What about 13? Yes, I can only divide it by 1 and by 13. What I recommend you to do is try it out with the numbers 2, 3, and 5 first. So in your head, divide this by 2, by 3, and by 5. When the answer is a number with a decimal place, then it is a prime number. So the result can only be a whole number. Now let's look at 15. Yes, I can divide it by 5, so not a prime number. What about 17? I can divide it by 2, not by 3, not by 5, so yes, it's a prime number. 20 I can divide by 4 and 5, so no, not a prime number. 24 also I can divide it by 4 and 6 and 2 and 8 and 3, so no, absolutely not a prime number. 25 I can divide it by 5, so not a prime number. What about 32? I know by tables really, really well, so I can divide by 4 and 8. That's just an example also. 2, so no. What about 37? Let me think about it. I can divide it by 2, I can divide it by 3, I can divide it by 5. I think that's a prime number. So yeah, let's move on to this one. I can divide it by 10 and by 4, no. I can divide this by 4 and by 11, so no. This I can divide by 12, also 4, also 2. 50, no. So I believe that these are my prime numbers, and then you go over it one more time, of course. If it is a test, you're not going to continue the next exercise. No, you check this first, and then you will see that these are prime numbers. Exercise T4 says, write as a product of prime numbers. What is a product? Times. So prime numbers times each other, and then the result must be 1425 in this case. What I recommend you to do here is start with writing down a number and its sign, and then in your head, you're going to try to divide it by 2, 3, or 5. These 3 numbers, you try that, okay? If you have to look at the last number here to check if it's divisible by 2, 3, or 5. This is a 5, so I can automatically divide it by 5. So it's 5 times, and then here is the leftover. So what is 1425 divided by 5? 1400 divided by 5 is 280, and 25 divided by 5 is 5. So I guess the answer is 285. Okay, then I'm gonna try to find more prime numbers. So I already have the 5. Now, what about 285? Look at the last number again. I can divide this by 5 again. So let's do that. 285 divided by 5 is 57. So 285, you can also write it down as 5 times 57. Okay, one more step. So 1425 is 5 times, let's see if I can make 57 a little bit smaller. Can I divide it by 2? No, because it's an odd number. Can I divide it by 3? Let's check it out. 30 divided by 3 is of course 10. 60 divided by 3 is of course 20, and this is 3 smaller than 60. So I believe that it's not 20, but 19. So 3 times 19 is 57. Okay, 3 times 19 is 57. Check it one more time. 3 times 10 is 30. 3 times 9 is 27. 30 plus 27 is 57. Yes. Hey, what about 19? Can I make that smaller? No, it's a prime number. So now I wrote it down as a product of prime numbers. 5 is a prime number, 3 is a prime number, and 19 is a prime number. Now I recommend you to do this in your head. 5 times 5 is 25, times 3 is 75, and times 19 has to be 1425. Check it out, because sometimes you forget a 5, or you forget a 2 or a 3, because sometimes you have 2 times 2 times 2 times 2 times 2, and then it's likely to forget one of the 2's. So please check it out before you move on to the next exercise. Exercise T5D says jx is 1/4 times 2 divided by x. And the question says, write these functions as one fraction. Now, 2 fractions times each other. You do the numerators times each other, so the top ones, and the bottom ones times each other. 1 times 2 is 2, and 4 times x is 4x. So that's 2, and this is 4x. Now, if I look at the 2 numbers over here, the 2 and the 4, I can immediately see that they are in the same table, so I can make them smaller, which means simplify. I'm going to divide this by 2, and I'm going to divide this by 2. This is 1, and 4 divided by 2 is 2, and then of course x. So 1 divided by 2x, this is the answer. T5e, Lx is 9 divided by x squared times 4x divided by 6. Again, numerators times each other and denominators times each other. 9 times 4x is 36x, and x squared times 6 is 6x squared. Now, let's see if I can simplify this. First, you look at the numbers and then at the letters. 36 divided by 6, I can both divide it by 6. So 36 divided by 6 is 6x, and 6 divided by 6 is just 1, so 1x squared. Now I'm going to look at the letters. There's an x by the power of 1 and an x by the power of 2. So I can both divide it by x. So the leftover here is 6, and the leftover here is x by the power of 1, but you don't have to write the 1. So it's 6 divided by x. T5f is 7x times 5 divided by 42x squared. When you do a product times fraction, I find it very helpful to also change this into a fraction. You can divide everything by 1, so just write it down like this. And then I can do the top ones times each other and the bottom ones times each other. 7x times 5 is 35x. And 1 times 42x squared is just 42x squared. Now I'm going to try to simplify it. Let's look at the numbers first. 35 and 42. I know my tables, and I know that I can divide them both by 7. This one divided by 7, the leftover is 5x. And this one divided by 7, the leftover is 6x squared. Sometimes you chose a smaller number to divide by, and then these are still pretty big numbers, then you can just look at the numbers again, and maybe you can divide it by another number, for example 2 and 3, and then you just do it one more time. Now if I look at 5 and 6, I can't divide it by any more numbers. So let me go to the letters, x by the power of 1 and x by the power of 2. I can divide them both by x. So the leftovers are 5, and then this is just an x, so 6x. So this is the answer, 5 divided by 6x. T6a says simplify the following functions. The first one is fx equals 16x plus 8 divided by 4. What I recommend you do here, when you do divided by 4, that's the same as times 1/4. So what I recommend you to do is use that 1/4 times this, 16x plus 8. And now you do it all times each other. So you do this times this, this times this. 1/4 times 16x, that's actually divided by 4, so that's 4x. And then 1/4 times 8, that is 2. So plus 2. This is it. T6c is Lx is minus 2 times 9x plus 14 in brackets divided by 4. There are actually two ways of solving this one, but let me just show you one of them. The same method that we just used, that divided by 4 is doing times 1/4. Now, but there's something going on over here, so let me just remove the brackets here first, and then I do that method. Minus 2 times 9x is minus 18x, minus 2 times plus 14 is minus 28, divided by 4. And now I'm going to use that method, so that's 1/4 times, and this in brackets. And then I remove the bracket. So 1/4 times minus 18x is minus 18 divided by 4 is 4.5. And this is also going to be negative. 1/4 times 28 is 7, so that's minus 7. Minus 4.5x minus 7 is the answer. This one is exactly the same. So you do use the method times 1/5, and first you remove these brackets, and then you can do times 1/5. But let me show you another way, because there's a times over here. What you can also do is first do 10 divided by 5, which is 2, and then you already remove the 5 here, because since there's a times here, that means that we're not going to do times 10, so everything in here times 10, but first we're going to do divided by 5, and then everything in here we do times 2. So you only have to do divided by 5, one of the factors. So choose this one. Let me show you. 10 divided by 5 is 2, so now the 5 is gone. And then, of course, I just copy this part in the brackets. And now I'm going to remove the brackets. 2 times 2.5 is 5, and 2 times minus 4.5x is minus 9x. And this is the answer. I think this way is a lot faster, but then it has more thinking steps. So perhaps that's difficult, and then you just do the other way. That's fine. So this was the video. Thanks for watching. Bye.